Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So today we are going to enter the third topic in STA404, which is estimation. So starting from this chapter, okay, you all dah kena pakai your statistical table, and I do believe that you all dah dibekalkan dengan statistical table sebelum ni, okay. You all juga akan kita akan masuk dalam statistics, which is a different dimension as compared to the previous one, where in this chapter we are going to look at inferential statistics, where we are going to try, okay, make conclusion about the population based on your sample. Okay, berbeza dengan topik sebelum ni, descriptive statistics, where you only describe your sample. So our focus in this video is method that can be used to estimate the population parameter from sample statistics. So I hope that you still remember, okay, parameter is any numerical descriptive measures that you obtain from your population, whereas statistics adalah numerical descriptive measures yang you calculate, yang you dapat from your sample. So the first part, okay, of this chapter is called sampling distribution of sample mean. Alright, so most of the time our population is large, okay, and we are not able to study all item in every population. So that's why, okay, normally instead of census, researcher ataupun people tend to do sampling. Okay, so because of that fact, we need to estimate our population based on the result that we obtain from our sample. Alright, so biasanya population kita sangat besar. Jarang-jarang sekali orang buat research, orang akan involve the whole population. Except for apa yang kita tengah buat sekarang, Malaysia tengah buat sekarang, which is banci e-census. Yes, that is a study that involve every element in your population. But perkara itu pun bukannya dilakukan setiap tahun, okay, because dia akan memakan masa, energy, cost, and etc. lah. So most of the time, okay, researcher would prefer sampling rather than census. So in this case, okay, in this chapter kita tengok sampling distribution of sample mean. So apa itu sampling distribution of sample mean? Okay, it's a distribution using the mean computed from all possible sample of a specific size taken from a population. Okay, so sampling distribution of sample mean ni sebenarnya adalah distribution of mean, okay, daripada semua possible sample yang you boleh keluarkan daripada population. Okay, contohlah dalam population ni kita ada 100,000 element ataupun unit dalam ni. So apa yang you boleh buat, you choose a sample from this population and dapatkan mean untuk that sample. Ambil lagi sample daripada population yang sama, calculate the mean. Take another sample from the same population, kirakan mean. Kita buat banyak-banyak, okay, banyak kali. So you akan ada mean daripada sample number 1, mean daripada sample number 2, mean daripada sample number 3, sampailah mean untuk sample n. So inilah yang kita namakan distribution of sample mean. Okay, okay, saya ambil satu contoh. I ask you all untuk conduct a study on average internet usage among Malaysian, for example. Okay, saya minta you all conduct a study. Saya divide you all into groups, tapi saya bagi you satu tajuk saja. Setiap kumpulan buat tajuk yang sama. So the first group, dia randomly select a sample, okay, and from the sample dia calculate dia punya mean. Dia dapat 8 jam, for example. Second group, on the same topic randomly select a sample. And from their sample, dia dapat 8.75 hours. The third group also randomly select sample from the population, and this group dapat 9.75 hours. The fourth group randomly select a sample from the population, and dia dapat 7.25 hours. And another group pilih sampel daripada population yang sama, dia dapat 7.75 hours. So in inferential statistics, you all nak make conclusion based on your population. You nak make conclusion about the population based on your sample result. So from here, kalau saya nak make conclusion about the population, result daripada siapa yang saya patut ambil? Is it fair saya ambil result daripada sample number 1 yang group number 1 buat dan neglect the other groups? Atau is it fair saya ambil group number 5 punya result dan neglect the other group? No, it's not fair. Because why? You all semua, okay, dalam contoh yang saya bagi ni 5 group, kelima-lima group ini pilih sampel daripada population yang sama. So sebenarnya result awak semuanya betul. Cuma disebabkan population ini besar, sampel yang kita pilih, okay, tak mungkin exactly dapat predict ataupun dapat estimate, dapat calculate the exact parameter for the population. So what should we do? Okay, in this case, apa yang kita boleh buat? Saya ada mean daripada group number 1, mean daripada group number 2, mean daripada group number 3, mean daripada group number 4, and mean daripada group number 5. From here, saya calculate another mean to represent the population. So, ini adalah distribution of sample mean, and saya calculate mean daripada the collection of mean yang saya dapat tadi. Alright? So, saya harap you boleh faham contoh yang saya bagi itulah. Okay? So, dekat sini dia kata, if repeated random sample of a given size n are taken from a population where the population mean is mu, okay? Kalaulah awak pilih random sample banyak-banyak kali daripada population yang mempunyai mean mu and standard deviation sigma, then the mean of all sample mean is this one, mu x bar, and the standard deviation of all sample mean is directly related to the sample size n is sigma x bar. Okay, apa yang dicuba sampaikan dekat sini adalah, okay, if your population mean adalah mu, okay, your mean untuk sampel-sampel yang awak dah cari tadi, the first sample, second sample punya mean, third sample punya mean, fourth sample punya mean, fifth sample punya mean, all this distribution sample of mean, awak calculate dia orang punya mean pula, mean dia akan mean dia ialah mu x bar, and sama juga untuk standard deviation adalah sigma x bar. Okay, since tadi saya ada mention, saya kata sampel ni tak mungkin boleh 100% really represent the exact population. Okay, so sampel yang you pilih ni tak mungkin a perfect representative of your population. Alright, so there will exist a sampling error. Sampling error ni is a difference between the sample measure and the corresponding population measure due to the fact that the sample is not perfect. Okay, perbezaan bacaan yang you dapat daripada sampel dengan bacaan yang you sepatutnya dapat kalau you buat census, that is sampling error. Perkara ini pastinya berlaku sebab apa? Kita tahu sample is not perfect. Kalau population awak ada 30 million people, awak pilih sampel, tak mungkin awak pilih sebahagian daripada population dan sebahagian itu boleh 100% represent the population. Dia mesti ada sedikit perbezaan. And this perbezaan is what we call as sampling error. But in statistics, we can reduce this sampling error by increasing the sampling size. So the bigger the bigger the sampling size, then you will reduce the sampling error. Okay. So your data can be distributed ataupun can be spread out in many different ways. Okay. Sometimes you mungkin ada data yang skewed to the left. You mungkin juga ada data yang skewed to the right. Mungkin juga ada data yang tak ada specific shape. You tak nampak a specific pattern pun. But most of the time, okay, kita would prefer data yang berbentuk bell curve. Okay. Many cases where the data needs to be around a central value with no bias left or right, yang kita namakan sebagai normal distribution. Okay, we see the data is normally distributed when the mean, median and mode are equal. Right, saya rasa you all dah tengok topik ni dalam descriptive statistics sebelum ni. Alright, normal distribution is when your mean, median dan mode sama. Dia symmetry about the center mu. Okay, shape in the same. Shape dia is the same on both sides. Okay, 50% on the left side and the other 50% on the right side. The curve must be continuous. Okay, curve ni, okay, dia mesti continuous. Dia tak boleh terputus. Right? And the curve actually never touches the x-axis. Dia just makin lama makin menghampiri x-axis, but it never touch the x-axis. And the total area under the curve must be 100 ataupun 1. That's why kalau total dia 100 and kita kata symmetry, 50% mesti dekat sebelah sini and the other 50% should be on the right side. Alright? So that is normal curve. Kita tengok central limit theorem. Okay, so like I told you before, most of the time the population from which the sample are selected is not normally distributed. Kadang-kadang ada yang skewed to the left, ada yang skewed to the right, ada juga yang tak ada specific shape. So in such cases, the shape of the sampling distribution is inferred from central limit theorem. So bila dia tak normal, kita akan gunakan central limit theorem ni. So dalam central limit theorem ni, apa dia kata? Dia kata the distribution of sample mean will approximate a normal distribution as the sample size become larger, assuming that all sample are identical in size and regardless of the population distribution shape. Tak kisahlah awak select sampel ni daripada population yang bentuk dia skewed ke, bentuk dia normal ke, atau dia tak ada exact shape sekalipun, tapi bila you buat you collect the distribution of sample mean, lama kelamaan dia akan approximate normal distribution. As okay, dia kata kat sini, as the sample size become larger. So large sample size tu adalah N30, lebih besar atau sama dengan 30. Kita consider the sample is large when N is greater than or equal to 30 samples. So this is what central limit theorem katalah. Okay, as the sample size get larger, so kita consider large ni adalah N greater than or equal to 30, then the sampling distribution become almost normal regardless of the shape of the population, regardless of daripada mana you select sample ni. As previously discussed, the distribution then will have the mean of the sampling distribution of X bar. So kita estimate population mean mu, okay, mu X bar, and the standard deviation of the sampling distribution of X bar is sigma X bar. So sigma X bar adalah sigma over Zn, yang sometimes called standard error. Okay, so sebelum ni you ada distribution of X follow normal distribution with mean mu and variance sigma squared. Sekarang kita dah estimate, so the distribution of sample mean follow normal distribution with mean mu X bar and variance sigma squared X bar. So these are a few example of normal distribution. Now, semua ni adalah normal distribution. Kalau you tengok shape dia macam bell shape, and area di sebelah kiri dan kanan almost symmetry. But adakah dia exactly sama? No. Alright. Even the shape is equal, tapi if you look here, the distribution of weight, mu dia 80, standard deviation dia 5. Height, unit pun tak sama. Mean dia 150, standard deviation 8. And this one, the last one, mark of test. Okay, even though dia normal, sama macam yang tadi, tapi mean dengan standard deviation dia tak sama. So, even though semua ni normal distribution, but kita tak boleh conclude yang mereka ini ada distribution yang exactly sama. So, sekarang ni, kalau saya minta you compare weight dengan height, boleh ke you compare? Tak boleh nak compare sekarang. Okay, kalau disuruh compare sekarang, you tak boleh compare. Untuk compare, okay, kita perlu standardizekan semua. So, macam mana nak compare distribution, okay, yang ada spread yang berbeza, yang ada mean yang berbeza, standard deviation yang berbeza. So, in order to compare different shape of distribution, kita kena transform dia kepada standard form, ataupun kita kena transfer dia kepada standard normal distribution. Standard normal distribution follow normal distribution with mean 0, standard deviation 1. So, walaupun sebelum ni mean dia 10 ke, mean dia 11 ke, bila you transform dia into standard normal distribution, mean dia akan jadi 0. And standard deviation dia akan jadi 1. Okay, so a normal distribution, okay, yang hijau ni normal distribution with mean 1010. Bila you transform dia into standard normal distribution, mean dia akan jadi 0 with standard deviation 1. So, macam mana nak transform? Okay, standard normal distribution is represented by the letter Z, and the total area under the curve still sama, equal to 1. So, macam mana nak convert? Okay, nak tukar jadi standard normal distribution, kita denote as Z adalah X bar minus mu over sigma X bar. And tadi kita punya standard error adalah sigma over Zn. So, untuk standard normal distribution, okay, nanti kita kena refer statistical table lah. So, untuk this topic estimation, kita akan refer dua table, table number 4 and also table number 7. So, kita tengok estimation. Okay, estimation where you nak estimate the population parameter by using sample statistics. So, type of statistics ada dua. Ini mula-mula hari tu you belajar. Type of statistics ada dua. Satu, descriptive statistics. Okay, consists of methods for collecting, organizing, summarizing and analyzing data. You hanya describe your data, sample data. Lagi satu type of statistics, nama dia inferential statistics, where in inferential statistics, method that use sample result to help make decision, conclusion, inference ataupun prediction about the population based on your sample result. So, untuk inferential statistics ni, kita ada dua method. Kita boleh pakai estimation untuk estimate the population parameter, atau kita boleh buat hypothesis testing. So, in this chapter, kita fokus on estimation. So, estimation is a process of estimating the value of parameter from the information obtained from a sample. Okay, please keep in mind that we can never know the actual value of the population parameter. So, apa yang you boleh buat, kita boleh estimate the population parameter menggunakan sample statistics. So, there are two types of estimation yang kita boleh pakai. The first one is point estimation, where A single numerical value is calculated from a sample data to estimate the unknown population parameter. Okay, contoh tadi, daripada sampel-sampel awak dapat mean dia 10. So, kita buat conclusion, population mean juga adalah 10. Ataupun kita boleh pakai lagi satu yang nama dia interval estimation. Interval estimation is a range of value within which the population parameter lies with a certain degree of freedom. So, kita estimate our population parameter dalam bentuk interval. Kita tak bagi satu exact estimation. Kita tak bagi satu single value untuk estimate the population parameter. Instead, kita bagi satu range. Our population parameter is between 115 to 150. So, kalau you compare point estimate, kalau saya suruh you estimate the population mean, kita bagi dia satu nilai, 123.45, mana dapat daripada sample mean. Dalam interval estimation, kita bagi range. The mean is within this range. Okay. So, kita tengok dulu point estimation. Point estimates ataupun estimator. Sample measures, okay, sample measures maksudnya value yang you dapat daripada your sample. Okay, kita namakan statistics. Used to estimate the population parameter. Ini dalam first topic you dah tengok. Statistics is a measure taken from your sample. Parameter is a measure taken from your population. So here, from your sample, you calculate mean, you dapat X bar. You gunakan X bar untuk estimate your population parameter. Contoh, population ada 1000 orang, sample 10. Daripada 10 orang, you calculate mean, dapat 3.5. 3.5 is your X bar. Kita gunakan X bar to estimate awak punya parameter. So, you estimate the population parameter menggunakan single value sahaja. So, mu tu parameter, X bar is your estimator, and the value estimate is 3.5. Ini contoh lah. So, ini adalah beberapa point estimates yang kita akan pakai dalam chapter ini. Kalau soalan suruh you estimate population mean. Population. Okay. So, dia suruh estimate population mean. Kita estimate population mean menggunakan X bar. Kalau soalan suruh estimate your population variance, sigma squared. Nak estimate pakai apa? S squared. If the question asks you to estimate the population standard deviation, kita estimate guna S. And kalau the population, kalau soalan minta you estimate for the difference between two means, so kita estimate pakai X bar juga. Okay, so this is point estimate. So properties of a good estimator should be unbiased. Okay, an estimator of a parameter is said to be unbiased if the expected mean is equal to the true value of the parameter. Kalau dia tak equal pun, dia close to the true value of the parameter. It should be efficient, okay, unbiased, and has a very small variance. Should be consistent. The estimator value approaches the true parameter. Variance should approach 0 as n increases. And sufficient. Make so much use of the information in the sample. Next, we are going to look at interval estimation. Interval estimates is defined by two numbers, okay, dalam range, between which a population parameter is said to lie. The estimate may or may not contain the value of the parameter being estimated. Each interval is constructed with regard to a given confidence level. Okay, confidence level ni apa? Confidence level is the probability that the interval estimate will contain the parameter. How confident are you yang awak estimate ni, range yang awak estimate ni, dalam tu ada the actual population parameter. So that is confidence level. Confidence level yang kita selalu pakai adalah 90%, 95%, 98% and 99%. Therefore, an interval estimate is also called a confidence interval, CI. So, macam mana nak cari interval estimates? The confidence interval is given as your point estimate tadi. Yang point estimate kalau mu, estimate guna X bar. Kalau variance, estimate guna S squared. Kalau sigma, estimate guna S. Kalau mu1 tolak mu2, kita estimate guna X1 minus X bar 2. So, your point estimate plus the margin of error. So, apa itu margin of error? Margin of error adalah your critical values darab dengan your standard error. Apa standard error? Standard error tadi standard deviation bahagi dengan set M. Okay, so untuk interval estimation tadi, dia punya formula adalah point estimates plus minus your margin of error. Your margin of error tadi adalah your critical value darab dengan standard error. So, standard error tadi sigma over sec n. Critical value ni apa? Critical value inilah yang kita kena cari daripada your statistical table. Okay? So, lepas ni, okay, dalam example, saya akan tunjukkan macam mana nak cari your critical value. This is another table untuk kita dapatkan critical values. So, like I told you before, kita akan refer table number 4 and table number 7. So, later I'm going to explain to you kenapa yang ini small sample, yang tadi large sample. Okay, so untuk small sample, okay, kita pakai T distribution table. So, T distribution table is used when the population variance is unknown. Itu yang pertama. Okay, resulting not normal or when the sample size is small. The T distribution similar and share the same characteristic to the standard normal distribution. Okay, tadi standard normal distribution ni apa? Apabila kita ada banyak distribution, okay, bentuknya tak walaupun dia normal tapi dia tidak exactly 100% sama. So, kalau kita nak compare, kita kena tukar dia jadi standard normal distribution supaya kalau nak compare, you compare apple dengan apple, orange dengan orange. So, kita tukar semua jadi standard. So, baru kita compare. So, apa karakteristik T distribution table? Sama juga, dia bell shape, normally distributed. So, bila dia bell shape, dia symmetric about the mean. Mean median mode are equal and the curve never touches the x-axis. However, the T distribution differ from the normal distribution in this way. Okay, the variance is greater than 1. Okay, kalau tadi normal, variance dia 1. Kalau T distribution, variance dia lebih daripada 1. The curve is based on degree of freedom. Okay, and as the sample size increase, the T distribution approach the standard normal distribution. Okay, maksudnya di sini, tadi kita pakai T distribution table kalau variance unknown and the sample size is small. Tapi kalau sample size tu makin lama makin besar, then the T distribution ini akan approach the standard normal distribution. Maksudnya di sini, T distribution kalau sample size ni makin besar, dia akan jadi standard normal distribution. So, apa dia properties of good confidence interval? Okay, it should be as narrow as possible. The narrower the interval, the more exactly you have located the estimated parameter. It has a large confidence coefficient. So the larger the confidence coefficient, the more likely it is that the interval will contain the estimated parameter. But how to get a confidence interval with large confidence coefficient and narrow interval? Macam mana you nak confidence tinggi tapi you nak narrow? So you have to increase the sample size. So there will be error in estimation. Error of point estimates, okay, the distance between an estimate and the true value parameter. Kalau untuk interval estimation adalah margin of error, the range of value above and below the sample statistics. The larger the margin of error, the less confidence one has that the estimates are close to the true parameter. Okay, so apa itu margin of error? Tadi dah bagi tahu, margin of error adalah critical value yang kita kena dapatkan from table dan juga standard error. Standard error ni apa? Sigma over Z N.